Okay, so linear differential equation. Okay, there are a form of linear differential equation. I can say dy by dx plus py is equal to q is a linear differential equation. Why I'm calling this as a linear differential equation? Because the power of this or degree of this dy by dx differential equation is 1. Okay, degree is 1. That is the first reason. What is the second reason? Second reason is degree of this variable y is 1. This is most important. Then only you can continue the following procedure, otherwise not. Okay, this shows that this is a linear differential equation. Okay, now what is this p and q? This p and q are the functions of x. They are the pure function of x. So we have to bring this in this particular format. Okay, now what is the working principle? The working principle is we have to find integrating factor. What is integrating factor? That's what we will going to discuss here. Okay, integrating factor is e to the power of integration of p dx. This is called integrating factor, and this y, where is that? Okay, y into e to the power of integrating factor, that is e to the power of integration of p dx is equal to integration of q, then again e to the power of integration of p dx, then whole dx plus c is the solution of the given equation. तो ये इंटीग्रेटिंग फैक्टर कहां से आया है वो हम देख रहे हैं. हमने क्या किया, जबरदस्ती मल्टीप्लाई कर दिया on both the sides by what? E to the power of integration of p dx. So I have multiplied this e to the power of p dx here. Okay, I have multiplied this e to the power of integration of p dx here. Now you will see here that derivative, now derivative of y e to the power of integration of p dx is what? Here you will going to apply u into v. U into v you will going to apply. So I will apply u into v here. dy dx of y e to the power of integration of p dx. This I am applying it. U into v I will going to apply. Okay, so when I'm applying u into v, first I will going to write u, then this v. So I mean derivative of this. So derivative of e to the power of integration of p dx is what? In e to the power of integration of p dx into derivative of this. So that will be your p only. Okay, this will be your p only, plus you will write e integration of p dx and then dy by dx. That's what you will going to write. Understood? So by doing this, what we did, now you can see one thing, that this e to the 1 minute. Now you can see one thing, that e to the power of integration of p dx and this e to the power of integration of p dx I can take common. So that's what they have taken common here. That's what they have taken common here. And then you are getting what? You are getting y into p. This y into p you are writing here, and then you are getting dy by dx. This dy by dx you are writing here. Okay, that's what they have considered. Now you know that dy by dx plus y p, this is nothing but your q. Okay, from where you have written this? From here you have written this is your q. You have considered that. मतलब ये चीज ये है, तो आपने इसको यहाँ लिखा है, और ये जो q जो है वो ये है. So q, ये पूरा चीज को आपने q में लिखा है. Okay, this entire thing you wrote as q, क्योंकि यहाँ पर दिख रहा है ना, ये देखो ना, ये on comparison this is equal to this and this q is equal to this. तो इसकी जगह आप एक q लिखोगे. ठीक है, और ये होने के बाद में आप क्या करोगे, इसको इंटीग्रेट करोगे. किसे? इसे इंटीग्रेट करोगे. यहाँ पर आपने इंटीग्रेट किया और यहाँ भी आपने इंटीग्रेट किया, तो क्या मिलेगा आपको? इंटीग्रेशन ऑफ q e to the power of integration of p dx, यहाँ लिख दिया. dx इज इक्वल टू, ये दोनों नलीफाई हो जाएंगे. क्या हो जाएंगे? नलीफाई. ये दोनों इंटीग्रेशन और डेरिवेटिव ये दोनों नलीफाई हो जाएंगे, और आपको ये मिलेगा. क्या? ये y, ये यहाँ आ जाएगा इधर. ठीक है, और फिर बाद में आप यहाँ लिखोगे y into e to the power of integration of p dx is equal to this plus c is the solution. Okay, so the question number 2 is, the slope of the tangent to the curve at any point is equal to y plus 2x. Find the equation of curve passing through the origin Means what he's asking? He is asking the particular equation, not general equation. So he's saying that, say there is some curve. Okay. Okay, this is the curve. And then on this curve, the slope of the tangent is there. Okay, on this curve, there is a slope of the tangent. So say I will have the tangent like this. Okay, so this is the tangent. Now this tangent, say the point of contact of this tangent and this curve is, say, x and y. So what it is saying? It's saying that the slope of the tangent to the curve at any point is equal to y is equal to 2x. So slope will be y plus 2x. Okay, the slope will be y plus 2x. That's what it is saying. Find the equation of the curve passing through the origin. It means I need to find the equation of the curve that is passing through some origin. So there should be a point 0 0 from where this particular curve is passing. So that will be what? That will be your particular solution. Okay, so it means that when x is equal to 0, then y is equal to 0. With that, arbitrary constant can be found. Okay, so slope, how we find the slope? We find the slope by differentiating this particular curve. So if I have a point, say xy, I will going to differentiate this particular curve at xy to get the value of slope. So dy by dx is already given to me, that is y plus 2x. Now this is a linear differential equation, right? Of which type? The type is dy by dx plus py is equal to q type. I have not brought in this type. I will going to bring this equation. I will going to transform this particular equation to bring in this linear differential equation format. Okay, so how to bring? I will going to transpose this over here. So I will get dy by dx plus minus 1 y, okay, is equal to 2x. Now when I compare this, I will get the value of p as minus 1 and the value of q as 2 on comparison. Okay, so here I'm writing value of p as minus 1 and value of q as 2x. Now since I have found which type of this linear differential equation is, then what is the second step? Second step is find the integrating factor. Here integrating factor will be what? E to the power of integration of p dx. What is your p? It is minus 1 dx. This is with nothing but e to the power of minus x. Okay, and what is the third step? Third step is the final step, that is the solution. Solution will be what? It is y into integrating factor. Y into integrating factor is equal to integrating factor into q dx plus constant c. So y I have written here, integration factor is e to the power of minus x. I have written here integration e to the power of minus x is integration factor. And what is q? Q is 2x. Now q is 2x. So LIATE exponential should be written next. So 2x I will going to write here. Here I will write 2 and here I will going to write x. Then dx plus c. Fine. So next will be y e to the power of minus x is equal to 2 is a constant. Here I will going to apply u into v formula, or by parts, integration by parts. So that says x into integration of e to the power of minus x, which is nothing but e to the power of minus x. Coefficient of x is minus 1, so I will going to divide with minus 1. Okay, then minus, again integration, derivative of x is 1. I am not writing it. Integration of e to the power of minus x is e to the power of minus x divided by minus 1. Okay, so let me make this plus 1. Minus into minus will become plus. So let me change here. Okay, minus into minus will become plus here. Okay, then it will be dx. This plus c will be here as it is. Now I have to book keep this in bracket. Now again, y e to the power of minus x is equal to, I am opening the bracket now. Okay, so it is minus 2x e to the power of minus x plus this 2 will come here, and integration of e to the power of minus x is nothing but e to the power of minus x, okay, divided by minus 1. So I am writing here this as minus 1, okay, plus c. Now this is a particular equation, okay, this is a particular equation, but what they have said, this particular curve is passing through the origin. So when x is equal to 0, y will be 0. So when I substitute the value of y as 0, this will become 0, this will become 0, and this will become e to the power of minus 0 plus c. So when I solve this, I will get the value of c as 2. Fine. Next what we'll do, we're going to substitute the value of c over here to get the particular equation. So my equation is y e to the power of minus x is equal to minus 2x e to the power of minus x minus 2 e to the power of minus x plus 2. Okay, this is my answer, final answer. So if you want, you can transform this minus part there and divide by e to the power of minus x. So this minus 2x when transfer here, it will become 2x. This minus 2, no, first let me write y. This plus y, then minus 2 will transpose here, it will become plus 2 is equal to 2. I am dividing by e to the power of minus x, so here it will become e to the power of x. Okay, this is the required equation of curve.